want to remind you of something. What does the expression I'm about to write on the page, what does it mean? 5x. What does that mean? Gurveer. 5 times x. Everyone agrees? We all know that, right? It's not x to the fifth, it's 5 times x. We're all cool, right? Okay. What does this mean? Which is 10. Cool. All right. Great. What does this mean? 5. Which is 10x. Good. And there's one other thing. Just let me move this up a little. What would... Ah! Oh, well, screw it. Who cares? What does this mean? 5x times 2x. 10x squared. Everybody can multiply, yes? Right? This is not new. We are cool, right? Okay. Logically, remember, if something happens in math, how often does it happen? Every time. So what does that mean? 5 times the root of 2. Everybody with me? It behaves exactly the same as 5 times x. Everybody cool? The 5 every single color of my pen is lit up now. There we go. The 5 is a coefficient, and it multiplies the very next thing, right? That's what this construction means, right? Okay. So, there's a horrible typo here. Multiplying radicals can only occur if they both radicals have the same... I don't know what happened there. I didn't proofread. That should say multiplying radicals can only occur if both radicals have the same index. Okay? So, root x times root y, is that okay? It's perfectly fine because that's a 2 and that's a 2. Everybody with me? Okay. Cube root x times root y. After tomorrow, that is okay too. But right now, is that okay? No, because they have different indices. Everybody cool? All right. Now, knowing what you know, if I gave you 5x times 3y, what would the answer be? 15 times x times y, but we wouldn't write those two times, right? We would just write 15xy. Everyone knows that, right? You took the coefficients and you multiplied them together, and then you took the next thing, which are called arguments, and you multiplied them together. That's how you do it. Does everybody see how easy it is? So look at this very first one. What are the coefficients, which I will highlight with yellow? -7 and 5. So the first step to multiplying these is to multiply the coefficients. What is -7 times 5? -35. Then the next step says multiply the arguments. Well, the arguments are what's attached to a coefficient, right? So what is attached to a coefficient? 3 times 8, which is 24. That's all you do. Everybody cool? That's how easy it is. Now, of course, is it really that easy? Of course you would simplify it. Just like when we multiply fractions, we simplify the answer, right? We're going to simplify here. And that's what we did yesterday. What simplifies to 24? And you just wrote a quiz on it. 24 is 4 times 6, yes? What's the square root of 4? So what comes out? 2. What's already out there? What's 2 times negative 35? Negative 70 root. What did I leave under there? 6. Easy peasy lemon squeezy. I know it seemed like we were going fast, but were we? It's all stuff you already know, yeah? Nothing new today. So let's have a look at B. There's some tricks in B that could mess you up. For example, what should be written there? 1. Do we ever write 1 as a coefficient? No, but it's there. So what do I do with 1 and 3? Multiply them. What's 1 times 3? 1 times 3 gets me 3. Then a root. And what goes here? 2. Sorry. I want to write it this way. Root 2 times 8, which is 16. And then we simplify. What's the square root of 16? So what comes out here? 4. Did we leave anything under there? So what's the answer? 12. Is B's lemon squeezy, right? So 1a is written the way we would have written in like grade 6, right? We actually put the time symbol there. Is C any different? No, because what math is happening right there? Multiplication. So what do we do with negative 8 and 6? We multiply them. What do we get? Negative 48. Root. What am I putting in here? 6 times 12, which is 72. And then what do I do? Simplify. 72. We've done 72 before. It's 36 times 2, right? What do I do with the 36? What's square root of 36 is 6, so what comes out? 6. What's already out there? So this becomes 6 times negative 48, which, just to save you from getting out your calculator, negative 288 root 2. So easy, right? Paige.
Why do you use the other one, like, you use the 6 for the number 1, use the 4, not the 6. You can break down 6.
6 breaks down into 2 and 3. Is there any pairs there? That's why, right? I only don't finish breaking down 6 because I know there's no pairs because I've done so many of these, right? You might want to break down 6, but then you wouldn't leave that as 2 times 3, right? Like if you borrowed $6 from me, right? And forgot you borrowed $6 from me and came back in 3 weeks. Said, hey, Myers, how much money do I borrow from you? And I said, well, Paige, you borrowed 1.5 times $4 from me. You would be like, shut up and punch me in the mouth, right? But if I said you borrowed $6 from me, you're like, oh yeah, of course, $6, right? 6 is simpler than 2 times 3. Picking up what I'm putting down? Okay. Everybody good? So what do we do with D? We do the exact same thing. What do we do with this 3 and what number's there? 3 times 1 is 3. Root 9. What is the root of 9? So what comes out here? And there's already a 3 out there. So what's the answer? 9. And we're done. Is everybody cool? It's super easy, right? Now, what all of a sudden happens in E that makes it not super easy anymore? Brackets and adding and subtracting. Now, you're smart kids. Obviously, exponents and radicals are related, right? Because x squared, square root of x, they're obviously related, right? And we know there's rules for multiplying exponents. Was there any rules for adding exponents? No, there wasn't, right? Because we had x to the 5th plus x to the 3rd. There was no rule for that. So do you think there's any rules for this? No. Bring other math knowledge to the party. Isn't this the same as 5x? Like it behaves the same way, right? And wouldn't this behave like 3y? Okay, so what would we do there? We'd have 15xy, right? What if I added 3z? What would that be? Who remembers how to do that? You've seen that before. No. What would you do here? 15xy plus what would you do here? 15xz. Can I put them together? No, because y and z are different. That's not like terms. You've all seen that in the 9th grade, right? At least that, yes? Okay, so you bring the knowledge that you already have to the party. You just learned something new, that you can multiply radicals. But they multiply the same way as variables, yes? So what do I do with the 5 and the 3 here? Multiply them. So I got screw it. Let's write it out the long way. 3 times 5, then a square root, and what's that? What do I do with the radicands here? What?
So I was going to ask, would you not do the things in the brackets first, and then the...
You can't add them together, dude. They're not like terms, right? That's an x, that's a y, that's a z, right? You got to bring the math you already know to the party. So we can't do anything inside there. So what's this going to be? 8 times 2, which is going to be 16. I'm going to write it all out. If you don't feel you need to write it all out, go straight to combining everything. Cool? Plus 5 times 2 root 8 times 3 minus 5 times 1 root 8 times 5. I like to show you everything at least once. So that is 15 root 16, correct? Plus, what's this one going to give me? What's this middle one going to give me?
And
10 root 24 minus, what's this one going to give me? 5 root 40. Now, I'm done all the new stuff, haven't I? I've done the multiplying. So now all that's left to do is old stuff, which is simplify. Does 16 have a square root? What is it? So what comes out? What's already there? 4 times 15 is 60. Plus, we got to break 24 down. We just broke 24 down in A, right? It was 4 times 6. And we remember that 6 has no pairs, so we leave it alone. What comes out from the 4? What's already out there? So what do I get? 20 root 6. Everyone agrees? 40. I would use 4 and 10. Why? 4 has a square root, and 10 we know, even if we break down, is 2 and 5, no pairs. So we're going to leave 10 alone. So what comes out? And what's already out there? So it's minus 10 root 10. Now, you're intelligent young people. These are different, aren't they? So it's just like having an x and a y, right? So can I add them together? No, so I'm done. That's finished. Is everybody good? Yeah? It's nothing new, right? The only new thing was the one thing at the beginning. Multiply the coefficients, multiply the radicals. Done. That's the one new thing, right? Now, if you only memorize steps, this is going to be very hard for you. Because what are you going to do? You're going to do the cubed root of what? 16 times 54, aren't you? And if you actually do that, that's the cubed root of 864. That's going to be a big factor tree, right? That's going to be like a redwood-sized factor tree. But isn't this already branches of the factor tree? So our first step is done for us, isn't it? So if we simplify first, we might be in better shape. Does everybody see that? What is the cubed root of 16? What should we break it into? Cube root. What should I use? What's a cube that goes into 16? 8. 8 times 2, right? So this is 8 times 2. What's the cubed root of 8? So what's coming out here? So I've got 2 cube root 2, don't I? What is a cube that goes into 54? 27. It's 27 times 2, isn't it? What's the cube root of 27? So this would be 3 cube root what? 2. Now, what am I multiplying? 2 times 3, which is 6, cube root. 2 times 2, which is 4. Which would you rather have done? Simplified 16 and 54 or simplified 864? Does everybody see what I'm saying? Why simplify something that's bigger when it's already broken down for us at our very first step? So the lesson that I want to give you here is, when should you simplify? In math class. Page. At the beginning, at the end, in the middle. When can we simplify? Every chance we get. Because what does the word simplify mean? Make it simpler. Is this the right answer? And then we'd break it down, yes? So we'd have to simplify anyway. But if we simplify here, we end up with the same answer. Everybody with me? All right. You try G. Hint, hint. What did I just say? Simplify when? When it's easy. Go. Anyone want the magic pen? I'll bring the computer to you. Simon, you want to do this question for us? Oh. Anybody want the magic pen? Don't all volunteer at once. I only have one pen and one computer to give out. Ezra, my man. What color, Ezra? Purple. Ooh, badass. My favorite color. Dun 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 dun. Doodaloo. Doodaloo. Do 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 do. Doodaloo. Look at this guy. Ho ho ho. That's cool. That's cool. Just leave it. We can all see that that's a root sign. You don't need to be so tough on yourself. Is he done? Has he done everything that I taught you today? Has he done it all right? So what's the one thing you should do to finish that off? What's the square root of 49? So what's coming out? No, 630 isn't coming out, Gervir. 7 is coming out, Gervir. Don't jump to the answer. Answer the question I asked. What's 7 times 9?
7 times 9? 61. I don't know,
63. And then add a 0 because it's 90. So what's the answer?
630.
There you go, brother. Does everybody see? Easy peasy, right? Now, if I were a betting man, I would say there's probably a couple of you that did stop there. Because you're like, damn, son, that was a lot of work. And you finished. Anybody honestly want to tell me they stopped there? Well, we know you did. Ezra, you did the thing. Right? But of course, is that anything to be down about if you stop there? Of course not, right? Because you know that the square root of 49 is 7. You were just so focused on what you learned today that you wanted to make sure you did it right. Right? Okay. Listen to me. Sadly, you only have 9 minutes left in class, but that's okay. 5 minutes left in class. See page 36 and 37 are almost exactly the same, yeah? But there's no answers. Okay? I am going to demand, this is work, I am assigning it, you've got 4 days to do it, and it's only 11 questions. That's 3 questions a day. 36 is an assignment, and it will be marked. 37 has a bunch of extra practice on it. Try a few of them, okay? But I'm not going to force you to do them. Now, normally I give you some practice before I mark anything, right? But the only thing we learned today is to multiply. And you know how to multiply, right? So I'm trusting you to be ready to go. All right?